Okay, so today we're going to be doing lesson 14-2, and today we're going to talk about the medians of a triangle. So we are on page 195 in your Springboard book, so open that up so we can go ahead and get started. So we're going to be determining the points of a concurrency of the medians of a triangle. Remember, concurrency is where all things join together. Okay, so the point where all of your medians are going to join up. So let's talk about what a median is. Okay, so we have this picture here, this triangle with vertices A, C, and G. And the points are listed there, okay, for A, for C, and for G. But we're going to draw in the medians for these triangles. Okay, and the median of the triangle is the segment from a vertex to the midpoint of the opposite side. So if I would start at A, for example, to find the median, I would draw that to the midpoint of the opposite side, GC. Okay, so in order to do that, the book's gonna kind of walk us through. So this was blank in my book. So if you want to kind of pause the video here to kind of fill this out, but all I did was scale the axes by going up by 2 on the X and the Y. And then I recopied this triangle, okay, onto my graph down there. So the same points for A, C, and G, I just kind of recopied it. So if you want to pause and copy that on your paper, that'll make it a little easier for you. Okay, so what we're going to do is we're going to start by writing the coordinates of the midpoints for each segment. So we have to find the midpoint of AC. So then we're going to call that point H. We're going to find the midpoint of AG, and we're going to call that point N. And then we're going to find the midpoint of CG and call that point E. So I listed the points here for A and C, A and G, and C and G. And we're going to have to find the midpoints of each of those. Now, if you forgot, remember, here's our midpoint formula. So remember, it's just the averages of each point. So the X's, you average those, you add them together and divide by 2. And the Y's are going to add together and divide by 2. So I'm going to have you guys take a moment here and find the midpoints for each of those. So use those order pairs that I already gave you and find the midpoint. So find points H, N, and E. Okay, so what I got for my midpoints, so for H, I got that is at 6, 12. Okay. For N, I got that N was at 18, 0. And for E, I got that E was at 24, 12. So what I'm going to do now is draw that in on each picture. So let's see, E 24, 12. Be right there. Label him E. Let's see. Then we have N, which is going to be at 18, 0. So there's N. And lastly, H is at 6, 12. Okay, so if we are going to draw in, okay, our medians, I would just have to go from that vertice here, okay, to that median that we just drew. It's from G, we'd go across to H then. Okay, similarly, I would do the same thing with C to N. And lastly, our last median from A to E. Okay. So remember, the point of concurrency is where all 3 of those points intersect. Now, my lines might not be the most straight because they should intersect at the same point. But we're going to get to that. So to determine the coordinate of where all those points meet, we have to write some equations here. So to determine the equation of ME, okay, what we need to find is we need to use, remember, we have to always find a point. Okay, so we're going to use a point. Ooh, that's not what I wanted. So we need a point that's on the line, and we need the slope the slope of AE. Okay, so if we're going to find a point, we can use any point, A or E we can use, okay? A might be nice and easy though, since it's 0, 0, so I'm gonna use that point. I don't know why this keeps giving me a highlighter. And then we need to find the slope of AE. So you could do rise over run there, so go ahead and find the slope of AE. But when I did it, I got a rise of 24 and a run, a rise of 12 and a run of 24. So for that, I got a slope of 1/2. So if I'm going to write the equation, remember point slope form would be y minus y1 equals my slope times x minus the x1. So that just, since those are zeros, just ends up being 1/2 x. Okay, so that's one of our lines here. So if we go on the next page, we're actually going to find the slopes or the equations for GH and for CN. Okay, so I copied our picture over here. But again, for GH, we need to find a point that's going to work. And we have to find the slope of GH. Okay, and same thing for CN. We have to use one of those points, so either the point at C or the point at N. And we need to find the slope of CN. Okay. So let's see. Let's see. I'm going to use point G because it has a 0 in it. So that's 36, 0. I apologize that it keeps giving me these green lines. I don't know how to fix that. And then if we find the slope of GH, okay, you can just use the points G and H. You can use the slope formula, or you could do rise over run. But for our slope, we should get -2/5. Okay, so our equation would be y minus y1 equals our slope times x minus x1. So y minus 0 is going to go away. Now, I don't really actually want to deal with the fraction, so I'm just going to leave this in the parenthesis form because I'm going to use Desmos here in a second. So instead of solving this by hand, if I was, I would distribute that -2/5 in, but let's just work smarter, not harder here. For number 5, the point I'm going to use is point C, so that's at 12, 24. And again, you can use point C or point N. I'm just using C. And then the slope for CN. So CN is here. If you find the slope of that, rise over run, you should get that the slope is -4. Okay. So now if we write the equation for that line, we'd have y minus 24 is equal to our slope, -4. And then x minus our x value, which is -12. Okay, so what we have here, I'll try to get rid of that line that I just put on there. Let's see, we're going to use these equations here, so I'm just going to try and circle these. Oh, this green is driving me crazy. And then we have our y equals 1/2 x from the other side. Okay. So to determine the points of intersection, okay, we need to solve this system. So again, we have the 1/2 x from the other page. And now we have our other two equations. So -2/5 times x minus 36. And then lastly, y minus 24 equals -4, x minus 12. Now we could have simplified those if we wanted to. I'm just not going to because I'm not going to solve the system by hand. I'm going to use Desmos to do it for us. So to find the point of concurrency, we need to solve this system. But remember, I showed you guys you could solve a system by graphing. Just need to plug it in here. So let's go to Desmos. I already have this set up for us. But if I graph each of those, and again, I kind of just typed them in without simplifying because Desmos will graph whatever you type in. But we can see here that they all intersect at one point. And that point is at 16, 8. So that is our point of concurrency, where all three things intersect. So let's go back to our notes. 16, 8 was the answer. Okay, and then that leads us kind of to one of the main parts here, which that point is actually called the centroid. Okay, the points of concurrency for the medians of a triangle is called the centroid. So if we find the equations, okay, of all of our medians, we can just throw them into Desmos, so we don't actually have to do this by hand because we already did enough work, in my opinion, by hand. But you just throw it into Desmos, and then that will end up giving you the point of concurrency. Okay, so let's just go through the steps one more time really quick. Okay, we would start by finding the midpoints of each line. So the midpoint of AC, the midpoint of AG, and the midpoint of CG. Then we use those points. Once we know where those are, we find the slope of those medians. And then use one of your endpoints, A or E, C or N, G or H. You can use whatever point you want, but you're going to find the slope of your medians and one of those points to write the equation. Now, technically, these are all supposed to intersect at one point. So you really only need to find two of the lines. As long as you have two equations, you can usually find their intersection. But if you want to make sure you really did your equations correctly, then you can find all three, because if you put it in Desmos, they should all intersect at the same point. Okay. So the median of a triangle goes from the vertex to the midpoint of the other side, and where they all intersect is called a centroid.